Hi, so here we are again on the next video for 5.1. This is says use the power rule for exponents. I like to call this a power to a power. And so one of the things you want to be careful of is not to get this mixed up with the product rule, because now we're on the power rule. So with the product rule we add the exponents, with power rule we multiply. So looking at this first example, y to the 8th to the 5th, notice that's a power to a power. This is equal to y to the 40th power. And then on the next one, we have 6 to the 28th power, and I'm just going to leave that way and not calculate it because it's so huge. And then on the next one, we're going to have -4 to the 6th power. And that's also a pretty big number. We could calculate it, and if we did, it would be positive. So let's see, that would be 4,096 if we went ahead and calculated it. So we usually don't when the numbers are so large. Now we have a power of a product and a power of a quotient. Basically, the power goes with everything inside the parentheses, whether it's multiplication or division. So on this first one, that's going to be a to the 6th and b to the 6th. Those both have an exponent of 1, so 1 times 6 is 6. Now on the next one, I'm going to go ahead and take 4 to the 2nd power, which is 16, and then x to the 12th, I multiply 6 times 2. On this next one, I have -3 to the 3rd, so that's -27. Notice there's really not a lot of work to show on these. You can just go ahead and write them this way. X to the 7th to the 3rd would be x to the 21st, y to the 3rd, because the exponent is 1, and z to the 6th. And that is simplified. All right, now let's look at this quotient rule, the power of a quotient, right? So on the first one, we have q to the 1st and t to the 1st, so that's going to be q to the 11th. Remember, it applies to both the numerator and the denominator, and t to the 11th. On the next one, we're going to have x squared, y squared, because both those exponents are 1. And then 7 squared is 49. Okay, next example. In the numerator, I'm going to have x to the 3rd and y to the 12th. In the denominator, I'm going to have -3 to the 3rd, which is -27, and z to the 9th. So you see, we just apply the exponent to each of the variables and numbers within the parentheses. Okay, so on this quotient rule, this means that we subtract our exponents. And so we're going to start with the numerator and subtract the exponent in the denominator. So this would be y to the 10 minus 9. So that's just y to the 1st. On the next one, we're going to have -6 to the 13 minus 11. So that's -6 squared, and that leaves me with 36. And next one, we're going to subtract the exponents on the x's. I'm not going to show steps on this one. So 8 minus 1 leaves me x to the 7th. 6 minus 5 leaves me y to the 1st. And we don't write the 1 whenever we just have an exponent of 1. On the next one, I'm going to simplify the numbers. So 3 goes into 27. 9 goes into 27 3 times. 9 goes into itself 1 time. So we're going to have a 1/3 fraction. And let's just do this. So 1/3 times, that's a to the 3rd and b to the 5th. Or we can write it this way, a to the 3rd, b to the 5th over 3. We don't have to write the 1 if those are in the numerator, and so both of these are proper ways to write this answer. Okay, the 0 exponent. So basically, we can take anything to the 0 power and get 1 except 0, because 0 to the 0 is undefined. And so 20, that means, and this, why this is true has to do with when we take, let me just show you a quick kind of process to show you what this means. So here's what happens. 2 to the third is 8, and if I divide it by 2, I get 4. Divide by 2, I get 2. Divide by 2, I get 1. And so that's really why something to the 0 power equals 1. And this may or may not make sense to you, but basically you just have to memorize. Okay, this is what happens when I take something to the 0 power. So 23 to the 0 is 1. 4y to the 0 is 1. This is negative 2 times x to the 0, so that's negative 2 times 1, which leaves me with negative 2. On this is negative 1 times 3 to the 0, plus 4 to the 0 is 1. So this is going to just be negative 1 times 1 plus 1. So negative 1 plus 1 is 0. Now I went kind of a long route here just to explain that to you, so hopefully that makes sense. 3 is the base, 3 is to the 0, but it's negative, so we have to take that into consideration. Okay, on this next one, if we take 2 to the third power and 3 to the third power, then we have 8 over 27. And that's it. On the next one, we have 3 times negative 5, so negative 15, and y to the 5th power. And then next we have to the 5th times 5 times 11, so t to the 55th power, right? Power to a power. And on the last one, we keep the 5, and when we subtract our exponents, we get x to the 6th power. Okay, so here's a bunch more stuff. I think this is the last slide, yes. And so we're going to take 2 to the 4th power, a to the 4th power, b to the 4th power. We're going to take 6 to the 4th power. You know what? I'm going to go back in a minute. I am going to simplify the 2 and the 6 because that's going to make this much easier. So I'm going to have 1ab over 3xz, and that's to the 4th. All right, so we have a to the 4th, b to the 4th. You guys, it's okay to simplify inside first. In this case, it was just better to do that. We don't have to work with big numbers then. 3 to the 4th power is 81. Then that's x to the 4th, z to the 4th. And we're finished with that one. We can't simplify anything else. All right, on the next one I have, that x looks weird. If I subtract my exponents, I have x to the 7th. And then 13 minus 7 is going to be y to the 6th. On the next one, so I have 9 to the 0 to the 4th. If I just multiply those exponents, I get 9 to the 0 plus z to the 0. So 1 plus 1 is 2. And we're finished with that one. Okay, this one looks a little bit messy, huh? Okay, so we're going to start here. I'm going to take 2 to the 5th power, which is 32. I multiply the exponents on the 6, or on the x, so 6 times 5 is 30. And then that's y to the 10th. In the denominator, this is what I have. And so here we go. So 32 divided by negative 32 is a negative 1. If I subtract the exponents on the x's, then I get x to the 10th, right? 30 minus 20. That 20 doesn't look too good. Let me rewrite it. And then on the y's, it's y to the 0. So now I have negative 1 times x to the 10th times 1, which is just negative x squared. And that's the end of this lesson.